Imagine every atom in your body. Now imagine every single one of them was forged in the heart of an exploding star billions of years ago. It sounds like science fiction, right? But it's a mind-blowing cosmic truth, and we'll reveal exactly how it connects to you later in this video. Ever wondered what a teaspoon of a neutron star would weigh? Brace yourself. It'd be about 6 billion tons. That's roughly the weight of all humanity, packed into a single spoonful. These incredibly dense objects are the collapsed cores of massive stars, so compact that their protons and electrons are crushed together to form neutrons. If you could somehow visit one, its gravity would be so immense, you'd be instantly flattened into a thin layer across its surface. Thankfully, they're usually hundreds of light years away, spinning at incredible speeds, sometimes hundreds of times per second. But even neutron stars are tiny compared to the mysterious force pulling entire galaxies toward it. Deep within the Laniakea supercluster, our cosmic neighborhood, lies something scientists call the Great Attractor. It's an immense, diffuse region of space with such powerful gravitational pull that it's dragging our Milky Way galaxy, along with countless others, towards its unseen center at millions of miles per hour. We can't see it directly because it's obscured by the zone of avoidance, a region of space filled with dust and gas that blocks our view. It's like a cosmic vacuum cleaner, subtly shaping the destiny of our local universe. And speaking of long journeys, imagine a craft launched over 45 years ago, still traveling further than any human-made object. Voyager 1, launched in 1977, is now over 15 billion miles from Earth, officially in interstellar space. It's moving at about 38,000 miles per hour, yet even at that incredible speed, it would take another 70,000 years to reach the nearest star system, Proxima Centauri. Its journey highlights the truly mind-boggling scale of our galaxy, a vastness almost impossible to comprehend. And the next fact might just make you feel even smaller. Picture our sun, 1,000,000 times larger than Earth. Now imagine a star so colossal that if it replaced our sun, its surface would extend past Jupiter's orbit. That's Scuti, one of the largest known stars, a red supergiant located nearly 9,500 light-years away in the constellation Scutum. Its diameter is estimated to be around 1,700 times that of our sun, meaning over 5 billion suns could fit inside it. To fly around its equator in a commercial jet would take an estimated 900 years. It's a humbling reminder of the sheer variety and scale of stellar objects out there. But amidst all that fiery grandeur, there's also an astonishing amount of something vital: water. Scientists have discovered a colossal cloud of water vapor orbiting a distant quasar, some 12 billion light-years away. This cloud holds 140 trillion times the water in all of Earth's oceans. It's the largest and most distant reservoir of water ever found, existing when the universe was just a quarter of its current age. This discovery suggests that water, the key ingredient for life as we know it, was abundant even in the early universe, hinting at vast possibilities. And speaking of possibilities, imagine a world drifting through the cold, dark void of space, unbound by any star. These are rogue planets, and astronomers estimate there could be billions, perhaps even trillions, of them in our galaxy alone, more than stars. They're ejected from their star systems during chaotic gravitational interactions, doomed to wander eternally. Some might even retain a warm core, potentially supporting subsurface oceans and primitive life. This silent, lonely existence challenges our traditional view of planetary systems. But what if time itself isn't constant? It sounds like science fiction, but time actually slows down near massive objects or when you move incredibly fast. This is time dilation, proven by Einstein's theories. Astronauts on the International Space Station, moving at 17,500 miles per hour and experiencing slightly less gravity than on Earth, age fractionally slower than us. While the difference is minuscule, just a fraction of a second over a lifetime, it's measurable. GPS satellites, for example, have to constantly correct their clocks to account for time dilation, or your navigation would be miles off. Don't worry, you won't notice time slowing down, but our sun's future will definitely be noticeable. In about 5 billion years, our life-giving star will swell into a massive red giant, expanding so much it will likely engulf Mercury, Venus, and possibly even Earth. The oceans will boil away, and our planet will become a scorched, uninhabitable cinder. Eventually, the sun will shed its outer layers, forming a beautiful planetary nebula, leaving behind a small, dense, white dwarf star, a dramatic, fiery end for our home star. And while our sun's demise is billions of years away, another cosmic event is on a collision course much sooner, relatively speaking. In about 4.5 billion years, our Milky Way galaxy is set to collide with our nearest large galactic neighbor, Andromeda. Don't picture a messy smash-up. The distances between stars are so vast that very few, if any, individual stars will actually collide. Instead, the two spiral galaxies will gracefully merge over billions of years, eventually forming a new, larger elliptical galaxy. It's a slow-motion cosmic dance on an epic scale. But what if we're missing most of the dance? Because despite all we've discovered, the universe is mostly missing. Scientists estimate that everything we can see, stars, planets, galaxies, all the visible matter, makes up only about 5% of the universe. The other 95% is composed of mysterious dark matter and dark energy. Dark matter doesn't absorb, reflect, or emit light, but we know it's there because of its gravitational effects. Dark energy, even more perplexing, is thought to be responsible for the accelerating expansion of the universe. We're essentially living in a cosmic enigma, surrounded by forces we can't yet fully comprehend. But even with all that mystery, we have a direct echo from the dawn of time itself. The cosmic microwave background, or CMB, is faint radiation permeating all of space. It's the residual heat from the Big Bang, the universe's first light, released when the universe was only about 380,000 years old. Before that, the universe was a superheated, opaque plasma. The CMB is like a fossil, a baby picture of the universe, offering crucial clues about its origins, age, and composition. It's a whisper from the universe's infancy, still detectable today. And here's the truly mind-blowing connection to you. The hydrogen in your body was formed in the Big Bang, but almost every other atom, the carbon in your bones, the oxygen you breathe, the iron in your blood, was forged in the fiery hearts of ancient, massive stars. When those stars reached the end of their lives, they exploded as supernovae, scattering these elements across the cosmos. Over billions of years, gravity pulled these elements together to form new stars, planets, and eventually, us. You are literally made of stardust, a cosmic masterpiece carrying the legacy of the universe within you. Follow Infinite's facts for more.